All right, in this third and final part of this video example, I'd like to work out parts D through G here to show you how you can use the regression equation that we found in part C to actually make predictions. All right, so let's go ahead and look at part D. So part D now is assuming that you've got the data in your calculator, your diagnostics were turned on, you found the regression equation and calculated the correlation coefficient, and now we're ready to start using the regression equation to make the predictions. So letter D says, predict the sales for an advertising amount of 6.1. Now I'm going to go to the data really quick. Notice advertising dollars, when you look down, you don't see a 6.1. Obviously, if it said, find it for 6.2, you would just read it off the table. Say, oh, for 6.2, it's $117,000, right? But notice there's no 6.1 here. All right, so then what's the point? Well, this equation we just found right here, that equation, which is called the regression equation, that could do a really good job predicting for this value. All right, so I'm going to take that equation. I'm just going to copy it and paste it. And that x value right there, I'm going to take out the x because I know what x is. The question's telling me use 6.1. So in other words, y prime, which is called the predicted value for y. Now don't forget what y means. Y means sales, x was advertising. So if the advertising is 6.1 and it's in thousands, what's the expected sales going to be? All right, well, I'm expecting sales to be 28.65 plus 13.9 times 6.1. All right, we don't do that in our head, obviously. So let's go to our calculator and let's clear all this mess out and crunch that thing. 28.65 plus 13.9 times 6.1. 113.44. All right, so 113.44. Now, obviously, we're talking thousands of dollars here, so that number is 11344, and then we have to move that decimal 3 places, right? Oops, let me put a comma in there. So this 113.44, because it's in thousands, which means multiply by 1,000, which means move the decimal 3 spots to the right. When you move that 1, 2, you got to add a 0 to the end. All right, so in other words, if you spend 6.1, which is $6,100 in advertising, you would expect to have sales of $113,440. Believe it or not, your calculator will tell you that without even having to do any of this, which is kind of nice. If I go over here, there's a feature that's built into the calculator that being that we have all the values and we have the equation, everything's on the screen right here. If I just tell the calculator, listen, give me the value and show me where it is for 6.1, it's going to give it to you. Now where it is, it's in this calculate menu right here, the trace key. So what you have to do is you got to go second trace. And it's the very first option. It's called value. Calculate me a value. So you choose number 1 for value. And notice it says, well, x equals what? What do you want? Well, I want it when it's 6.1. So you go 6.1, enter. And look at that. Not only does it tell you the answer down here, which is 113.44, same thing we got, but it even blinks right here, as you can see, and it's showing you where it is. It puts an X and marks it right on the graph, which is kind of nice, obviously. All right, so let's go back to the, and by the way, you could do this either way. You could use the second calculate feature, or you could just plug and chug into the formula. That's up to you. Letter E. Is the predicted value in part C interpolated or extrapolated? And then it says explain. All right, well, this is assuming that you've read that little blurb on interpolation and extrapolation in our textbook. Remember, this regression equation right here, this one that we're using to predict, works great as long as we are within the values of these x's right here. Now, what's the lowest value? Let's see. The lowest value, I think, is at 5.5 right there, right? I think that's the lowest one. And the highest one looks like this 6.8, I suppose. So this regression equation will do a fine job. That regression equation is fine as long as I pick values between 5.5 and 6.8. Our number that we used was 6.1, which notice is within 5.5 to 6.8. So in other words, I feel comfortable using this regression equation to make that prediction because of that. Now, when you do that, that's called interpolated. In other words, inter meaning within. So the 6.1 is within the high and low values. So we feel safe doing this. So is this value in part C interpolated or extrapolated? It is interpolated since 6.1 lies within the given x values. Okay, let's look at letter F now. Letter F says, if you were told the sales are 125, what would the model predict for advertising? All right, so wait a second. Sales are 125. All right, well, sales is Y. All right, so in other words, this equation right here, which I'm going to copy it again, paste it over here. The value of Y is 125. So let me paste it one more time. So I'm going to take that thing out right there and put 125 in its place. All right, well, that's just a little Mickey Mouse equation that you got to solve. And you know how to play this game. You have to subtract 28.65 from both sides of the equation. I'll do my best here to make this look pretty for you. All right, it's close. I mean, you get the idea here. I'm trying to work an equation on the on Microsoft Word, but you get the idea. So what happens is, so this 28.65, I want to cancel it. So what I'm going to do is subtract it from both sides of the equation. So in doing so, I'll have to subtract it. So these will cancel. 125 take off this. Right, I'm going to do that on the calculator. So let me clear this mess out. So 125 subtract 28.65. 96.35. Okay, so let me pop it over here. 96.35 equals 13.9x. And by now you should know, now there's no way I'm going to be able to show this in Microsoft Word, but to do this, I'm going to want to divide both sides by 13.9. So x equals 96.35 divided by 13.9. So x equals, and we'll do this on our calculator. So this 96.35 divided by 13.9 would be about 6.93. Okay, so this would be about 6.93. So that means we spent 6.93 on advertising. Now, obviously, don't forget it's in thousands. So that's really, you move that decimal 3 spots to the right. That's $6,930. All right, so this involved obviously solving an equation. Now, how come? Why is this one different than Part D? Part D, we just put a value in for x and multiplied and add, and we got that 113.44. Why was this one so much more difficult? Well, because they didn't give us the value for x. They asked us to find the value of x. They instead gave us the value of y. So I plugged in the value of y, and then I had to solve this two-step equation by bringing this number over and dividing both sides by 13.9. All right, so there we go. So the x value is 6.93. Letter G says, would you trust the model's prediction for the value you calculated in part F? Why or why not? All right, well, let's give it a look. 6.93, that's a problem actually, because look, remember the lowest value is 5.5. The highest value is 6.8. So remember, we discussed this already. We feel comfortable using our regression equation, this equation right here. We're comfortable using this equation for values that live between 5.5 and 6.8. The value for x we just got was 6.9. All right, obviously that is outside of the range of values for x, meaning it is extrapolated. So this question in part E, when it talked about an interpolated or extrapolated value, and the value that we use, the 6.1 was interpolated because it was inside that range. That 6.93 is not within that range. And just for the record, as you can see, that 125 is not in the range of the y's either. Notice the highest y value, what is it? Yep, that highest y value is right there, 123, right? So the fact that we're using 125 is outside of the range. Clearly this is extrapolated. So it says, would you trust the model's prediction? And I would say no, I would not, since the value is extrapolated. Again, extrapolated means we're using a number that is outside of the given data. You see the problem with that, if you're wondering why is that a problem? Well, when you go back to the calculator and look at the data, that's like saying, that's a big assumption to have to say that, this line, this data is, moving in a linear trend. And what we're doing is we're predicting off the screen. And, the idea is we don't know what happens over here. And we don't know what happens over here before. So, before the line begins and, after, what if this data kind of tails off and gets really flat? Or what if it starts to grow a lot faster? Like, we would never know that. So that's why we're only safe predicting in this range here. Outside of that range, we call that extrapolated. And that's why we don't trust Part G's model. All right. If you have any questions, message me on Blackboard. I hope this helps. Thanks for watching.